Good morning to everyone. In this video, I am going to discuss about knapsack problem with 0 or 1. In the previous module also, we have discussed about knapsack problem, but we applied greedy mechanism to find out the optimal solution. But in this video, I am going to apply dynamic programming mechanism to find out an optimal solution in the knapsack problem. When we are discussed about greedy method for solving this knapsack problem, we have known the previous solutions and accordingly we have found it everything. But in those case the objects are divisible, that is we have used fraction method, but here we are not at all using any sort of fraction method. Either we will take an object or we will reject an object. That is the two condition. Only we can accept or take the object or we will reject the object. If I am take the object onto my container bag, then value 1 will be set. If I unable to bring that object onto my container bag, then 0 will be set. This knapsack problem is also called as container loading problem. That is, I have a container with certain capacity and also I may have certain set of objects. I have to bring one by one objects, then I have to fill up my bag. So when I fill up the bag with the object, it must have a maximum profit. So for that purpose, I am applying the dynamic programming mechanisms here. Now, let us discuss what is knapsack problem. The value and mass of each item is given. Here, one item with 2 kilogram, price 1, profit is 1. Another item is 2 kilogram with 2 rupees profit. Third kilogram 2 rupees profit, 3 kilogram 3 rupees profit, again 3 kilogram 4 rupees as a profit, 4 kilogram 6 rupees as a profit, 4 kilogram 8 rupees as a profit. Now I have to choose one by one item from the set of given item, then I have to fill up the bag, where my bag capacity is 15 kilogram. I cannot load any extra item afterwards, and also I cannot split the items into two. I cannot break the item into two to load the object into the bag. So that is what, this is not a fractional method. When we are applying greedy method, we have seen fractional method, but here we cannot take any fractional value. If the first object is loaded into bag, then it will be set to value 1. If I unable to take third object, then third object value will be 0. That's what 0 or 1 problem for this knapsack method. Now consider this example. In this example, I have a bag with a capacity of 20 kilogram. Assume that 20 kilogram. I have 1, 2, 3, 4, 5 objects, 5 items, where Wi represents weight of each item, Bi represents benefit value, that is profit of each item. 2 has weight. If any item weight is 2 kilogram, then the profit will be 3. 3 kilogram profit will be 4. 4 kilogram profit will be 5. 5 kilogram profit will be 8. 9 kilogram profit will be 10. So from this given set of item, I have to pick one item, then I have to load it into the container bag, which has the capacity 20 kilogram. So this is called as knapsack. Now next, 0, 1 knapsack problem means the items are indivisible, that I told you already. Either we can take the item or not. Some special instances can be solved with dynamic programming. Fractional knapsack problem, that is items are divisible. We have discussed regarding fractional knapsack problem by applying greedy mechanism. So now, given a knapsack with maximum capacity W and set S containing n items. Each item has some weight as well as profit. Profit or benefit. Profit means capital P will be denoted. B represents benefit value. Now to find out the formula for this, I am going to choose a maximum value with summation of benefit of an object with weight of an object. So both should be in summation. So that's what summation of I belongs to T Bi to summation of I belongs to T Wi. This problem is called a 0-1 problem because each item must be entirely accepted or rejected. If I accept an item, then 1 will be represented. If I reject an item, then 0 will be represented. Let us solve the first problem with this mechanism. Since there are n items, so 2 to the power of n possible combinations of items. For example, if I take 4 items, then if I unable to consider all the 4 items, then 0, 0, 0, 0 will be represented. If I consider only third item, then 0, 0, 1, 0 will be represented. If I consider only first item, then 1, 0, 0, 0 will be represented. Likewise, I can take 16 combinations for 4 objects. So, if there are n objects, then it will be 2 to the power of n. So, time complexity will be order of 2 to the power of n or big O of 2 to the power of n. Next, we can do better with an algorithm based on dynamic programming, and some sub-problems also we can use to find out the better solutions. Now consider this example. In this example, back size is 5. Assume that back size is 5 and I have 4 different objects. So if back size is 5, then it will be started from 0 to 5, and 4 different objects means from 0 to 4. Along with the 0 I have to take. Now I have to fill up this table. How I am going to fill up this table here is, the items are 1, 2, 3, 4 and each item will carry the weight from 2, 3, 4, 5 and 3, 4, 5, 6 are benefit or profit respectively. That is, for item 1, weight for an item is 1 is 2 and benefit is 3. For item number 2, weight is 3 and benefit is 4. For item 3, benefit is 5, weight is 4. For item 4, weight is 5, benefit is 6. Benefit or profit, whatever it is. First, 0, 0, I have to put 0 because 0 means no object has been chosen and there is no weight at all. In the row represents weight, column represents the items. See here, 0, 0, I will put 0 because none of the weights have been chosen for none of the objects. Next when I take the first object, its weight is 2, benefit is 3. Weight is 2 means 1, 2 I can write the benefit of the first object. So in 1, 2 I will write 3. In the next slide I will write it down. 1, 3 I will write 3. Now the remaining 3, 4, 5 I cannot fill up anything because the first object weight is 2. So it's 2 kilogram of weight of an object can be fill it over the back. For that I had written the benefit. Then the remaining and all, it cannot be chosen. So everything will be 3. Next also 3. Next also 3. Next I will choose second object. For second object, weight is 3 kilogram. Benefit is 4. So weight is 3 kilogram means for second object weight is 3 kilogram. Benefit is 4 means I will write 4 in 2, 3. When I am writing 4 at 2, 3, Before that, before 2 comma 3, 2 comma 1, 2 comma 2 is remaining. In those places I can consider about the previous value, previous row's value. Here when I consider about the first object, I can ignore the remaining 2, 3, 4. When I consider about the second object, I can combine the value with the first object, but I can ignore third and fourth. When I consider about third object, I can ignore fourth object value, then I can combine third to 1. Likewise, the above values can be combined together, but I can ignore the below value. So according to that, 2 comma 4 second object value is 3. So 2 comma 3 I can write 4. Before that and all I can write the previous values, previous rows values. So 0, 3. Next 4 will be written. Okay. Next I can combine the value. When I combine the value, 2 plus 3, weight of 2 plus 3 will be 5. So in fifth object I can write 1 plus 2, 3. But if I write 2 comma 5 as 3, what will happen here is, initially profit will be 0, then profit will be 0, then profit will be 2, 3, then profit will be 4, then profit will be 4. Afterwards profit will be decreased, so I cannot choose. Next what will happen, 2 comma 4 also 4 will be taken, 2 comma 5 also 7 will be taken. How I am choosing 7 here is, I am combining the profit value. So as I said before, in 2 comma 3, when I combine the values of 2 comma 3, total is 5. Weight of first and second object, total is 5, but the profit is 3 plus 4, 7. So in 2 comma 5 I will write it down 7. Next I am going to consider about the third object. In third object weight is 4. So in 3 comma 4 I will write 5. Before that and all I will choose the previous row's value. So accordingly 0, 3, 4 I have taken. Next 3 comma 4 I will write 5. 3 comma 4 I will write 5. Now I can combine the above two objects. When I combine the above two objects, the weight will be 4 plus 3, 7, 7 plus 2, 9. It exceeds the limit. If it exceeds the limit, I cannot fill up the objects in the back. So what I am going to do, I am going to choose the previous cell value as it is. Next what I am going to do, I am going to consider about the last object. When I am considering the last object, total weight is 2 plus 3, 5, 5 plus 4, 9, 9 plus 5, 14. But my back size is 5. I cannot adopt those objects into this. So what I am going to do, in 4 comma 5 I will write the same value 7 from the previous one. Now back is full. I cannot load any other object afterwards. Next what I have to do, I have to choose what are the objects I can choose from the given set of items and what are the objects I can reject. So if I choose any items, then I will keep it on my bag. So for that purpose, the largest value in this table is 7. So I will take 7. 7 is for fourth item. I will check whether 7 is present in the previous row. Yes, 7 is present in the previous row. So it not depends on the fourth row. So fourth object I will reject. I need not have to take. Then next what will happen? Third object also I cannot take because number 7 is appearing in the second items. So I will choose second. I can choose second. Next what can I do? I will compare 7 with the previous value 3. I am going to check it out whether 3 is present in the previous row or not. Yes, 3 is present. Afterwards is 3 present? No. So I can select the second objects. So I will select second objects as well as first objects. Second objects also I can take, first objects also I can take. So second object first object I can take, second objects I can take. Next what will happen? The remaining 0, last column will be 0. 0 is not only present this, it's also appearing on the previous one, so I cannot take. So only 2 objects alone I can take from the given set of items. That is, first one I cannot take, so in first object 0 will be represented. Second object I can take, so 1 will be represented. Third object I can take, so 1 will be represented. Fourth object I cannot take, so 0 will be represented. In dynamic programming, it's very useful technique for solving certain kind of problems. When the solution can be recursively described in terms of partial solution, we can store these partial solutions and reuse them whenever it is required. And running time of dynamic programming algorithm versus naive algorithm will be order of w into n versus order of 2 to the power of n. This is called as knapsack problem 0, 1. Thank you.